Hi, I'm Bob from Hauptwerk Hardware, and in this video we're going to take a look at this. It's the System 1 Lighted Rocker Tabs Interface 16, and as its name suggests it can accept up to 16 lighted rocker tabs, but we're also going to take a look at this, which is its big brother, which takes up to 48 lighted rocker tabs. So let's get on with it, get these on the bench and see what we can do with them. I've got the lighted rocker tab controller on the bench now, and it's plugged into the System 1 main control board, which we've seen in all the other videos. So I'm just going to move that out of the way as much as I can to give us a bit more room. The second socket along here, which is marked lighted stops, is connected to our little lighted rocker tab 16 interface. And we've got the green light on, so that's good news. And I've also just got an LED here, and I've used these little test leads just to hook this up. So this, the black lead goes to ground and the red lead goes to the LED outputs number 1. So this would just be the same as soldering it to that number 1 solder pad there. And then other than that, nothing else connected to it at the minute. And if we move across to the computer, this has just been started up, so we get the normal sort of output from the controller. This is the power management stuff that I've mentioned in the previous videos, and prior to that it just says the controller's ready, so that's good news, that's all ready to go. And then on the MIDI side here, we can see that we've got this MIDI data which has come from the controller when it was started up, and so we've got a note on and we've got a note off. And that's these two notes here, which is the power management stuff which we've spoken about. So that's all good, that's ready to go. I've got a USB to MIDI converter, adapter, call it what you will, the little Turtle Beach one that we've used before in our other demonstrations, and that's connected to the main control board via the 5-pin DIN, and this is the other end of it, obviously. So our output port is connected to the Turtle Beach and our input port is also connected to Turtle Beach. So basically anything that comes from our System 1 control board will end up being logged here, and anything we send here will go to our System 1 control board, and we can see what we've sent by looking at the MIDI out monitor here. So that's the setup that we've got so far. So coming back to what we've got on the bench then, along the bottom we've got this matrix rows and matrix columns. So you'll see that there are only 2 columns, which is different to the other things we've looked at, and that there are 16 rows. Again, that's different. So it's a 16 by 2 matrix, so obviously 2 16s are 32, and that's what gives us our on-off for each stop for 16 stops. And that's how that works. We've got our 2 sockets here, which we'll look at in a little while, and that's pretty much it. So what would happen if I take my little test lead, which we've used previously, if I connect column 1 to row 1 on this matrix here, then that will switch on the first rocker tab, and when it does, it's going to make this little LED light up. So not only that, when we look at the computer, we'll see what it sends to that as well. So if I touch column 1 to row 1, so now we can see our LEDs lit up, and if we look at the computer, we can see that it says it's sent note on 0 on channel 8, and then over in the MIDI here, we've got that here. So note 0 in channel 8, and 7F is the velocity, which we don't really care about for this. We just need it to be a note on with a velocity of more than 0. So if I now touch row 2 to column 1, that will switch that stop off, or rocker tab off. So you'll see that the LED will go out and it will send the corresponding note off for 0. So if we do that, so that's the LED's gone out now, and if we look at the computer we can see that it says sent note off channel 8 0, and we can see on the MIDI monitor that that is exactly what it's done. and it works in reverse as well. So if we send it a note 0 on, so we'll do that. It's come up and said lit stop 0 on the computer there, and if you look at the this is tricky to do because I don't want to be moving that around like I just did, but let's try and keep that on there. So this is obviously lit up now, so when I release this, it's going to send a stop 0 off and the light goes out. So shame I couldn't hold it still really, and we got all this other sort of spurious stuff in between, but not to worry, it's not going to cause us much of a problem going forwards. But you can see how that works from what I did there as I moved the mouse along the keyboard accidentally. It's sent all of these on and off commands for all of the different stops here until we get to the last two when I managed to hold it steady on note 0. So that's how that responds, and we can see the MIDI that was sent to it there as well. So coming back to our board now, the next thing to look at really is these two sockets, because obviously if you wanted to just connect this up to a bunch of stops and to create your own matrix, that would be very easy to do. You've got the rows and you've got the columns, you just connect those up, and you've got the outputs to your LEDs along the side here and you connect those up. So nice and easy. However, the idea of these two sockets is that we can easily connect this. If I just move it out of the way for a moment, we can easily connect this to one of these things, and these rocker tab circuit boards, whatever you want to call them, they seem to appear all over the place. I've seen lots and lots of organs with these in. They're not always exactly the same. Sometimes they're wired slightly differently, but the basic idea, just a bunch of plastic rockers on top of a printed circuit board with a bunch of switches. And I've got one over here which doesn't have any of the rockers on it, so that's the same as that, but just with the plastic rockers removed. So if we turn these over, you can see they're very similar. Turn them around the other way. So the bottom one obviously is shorter than the top one, and that's another feature of these type of boards, and probably why they're so popular, is that because of the way they're made and because of the way they're wired, you can cut these down to fit as many stops as you need. Obviously the maximum, or possibly not obviously, but the maximum you can have on here is 16. That's the biggest boards they do. But if you don't want to use 16, you just chop off the board at the point where you don't need it anymore. So if, for argument's sake, you only needed 4, you just literally cut the board through there and throw this end away, and you just have these 4, and that would be, you know, all you'd need. It might be a bit problematic because the socket in the middle is for the LEDs and you don't want to chop that off, but basically you're not going to have a board or an organ with just 4 of these rockers. So 1, 2, 3, 4, 5, 6. So anything after 6 you can just cut that board away. And some organs do. You know, I've seen them with kind of 7 or 8 or 9. If they're fairly small organs with, it's usually on the pedals actually. When they don't have too many stops for the pedals, they can cut these right down. But just be aware that they do all come in kind of different lengths, and that's possible because of the way the board's actually wired. So whoever invented these, yeah, kudos to them. It was a very good idea. And they're just easy to use in whatever size you want. So let's get that one out of the way and have a look at this one. Now, it's got its diode matrix all on board, so we've got all of the diodes here all the way along, and we've got 2 sockets on the board. This one's a 16-way, with got these little things that just lock the plug in. But that's just like a 16-way IDC thing, which you can see there. And this one is a 20-way. And the idea is that this one is for the matrix connections and this one is for the LEDs. So in theory, it's nice and easy just to get a couple of ribbon cables, and we can take our 16-way ribbon cable and plug that the right way around, preferably, into our LED socket. And we can just plug the other end of this into the LED socket on our matrix interface there. So what should happen now, if I turn this the right way up, and this will not work, I suspect, when I try this, but we'll just try for a second. So if I turn that on again, that stop should light up. You can see that, or well, you can't see because it's out of the shot here, but our little, if I get the mouse in the right place, our little LED lights up here, but our stop doesn't. And the reason for that is because this particular board, as I said, so they're quite often wired differently. This board has got the ground for the LEDs here. Some of the boards have the ground for the LEDs on this socket. So that brings us on to the next thing to look at, or the next feature, if you like, about these boards. So if I just unplug that for a moment, move it out of the way, and get the LED out of the way as well. And I'm just going to zoom the camera in now so that we can look more closely at these sockets. Okay, so with the camera zoomed in now, you can see that for this LED socket and for the matrix socket, down the side of them, there are two rows of connectors, either side of each socket. And the idea of this is that the inner solder pad all the way down there is connected to the pins of the socket, and the same this side, the inner solder pad is connected to the pins of the socket. So right now, if we just plug a cable into here, nothing's going to work because it's just going to bring the connections of the cable to these pins, and they're obviously not connected to anything else yet. The outer pins with the numbers are the pins that are connected to the actual electronics of this interface board. So if it's a one-to-one kind of relationship, which this will be, because I know that this particular board is wired so that LED 1 comes to this pin, 2 comes to there, 3 and so on, round to 14, which comes to this pin here. So all I need to do to make that work is just put a link across each of these solder connections here, which will then connect this socket to the correct function, if you like, on the actual matrix interface, or the rocker tabs interface. Now 16 and 15, there's only 14 stops I think on this board, so that won't be used. Let me just double check that. 1 2 3 4 5 6 7 8 9 10 11 12. Yeah, there's only 14, so I don't need to put the links across the top here. Now you'll notice also that there's a ground pad very close to these connections, and the idea of that is that, as I said earlier, on these stop boards, this particular one we're going to use has got a separate ground pin on the back of the stop board, which we need to connect to ground somewhere on our system. But some of the boards don't have that, and they actually use pin, it's either 15 or 16, I can't remember which one, but one of those two, they use that as the ground for the LEDs. So in that case, if it was 16 for example, you would need to connect this point to ground rather than to to the number 16 LED, which would be here. So that's the idea of that, and then it's exactly the same for the matrix. Now the way these are presented, again, the inner ones are connected to these pins on the inside of the socket, and the same on this side, and then the ones on the outside are connected to the electronics of the matrix, and they're all labelled. So we've got common 1 here, common 2 here, and common 1 here and column 2 there, duplicated on the other side. Again, that's because some of those stop boards use these 2 pins for the columns 1 and 2, some use these 2 pins, and on some they're actually connected across together like that. And then our rows start here with 1, and then they kind of work round this way. So we've got 2, 3 at the top, 4 at the bottom, 5, 6, 7. So they work from the centre out. All those boards seem to be wired that way. But if you get a board that is not wired that way, let's say for example that column 1 on your board actually came up on this pin down here, then the idea of these solder pads is that you can actually run a wire between this pin and column 1 if this was the column 1 on your board, and if this happened to be column 2, you can run a wire from there to column 2, and then if row 1 started here for example, you'd run a wire across to our row 1 there, and if the next one, let's say row 2 was over this side, for example, you could again just run a wire across to here. It would get a little bit untidy, but the alternative, of course, is that you would have to take the ribbon cable, cut the plug off, strip all the wires back, and then solder them all along here. So it just gives you options, really. I mean, if you wanted to go that way, there's no problem in doing that. You can just cut that plug off and you can solder the wires along on these solder pads and not bother using this socket at all. But if you want to keep it nice and neat, and you can do so, then obviously plugging that in there once you've finished with your wires underneath is going to be much easier to work with, and it's going to look nicer as well. So that being the case, what I am going to do now is that I'm going to put links across for the matrix on this board, and we know that this one is just a one-to-one relationship, so I've just got to connect these together, and I've got to do all of them obviously on the matrix plug, and then on the LEDs plug I'm just going to do from here downwards on both sides, because the top two, 15 and 16, are not used. So we'll come back and have a look when I've done that. Okay, so as you can see, I've put all these links across as I was about to do. I haven't bothered with the top two for the LEDs because there's only 14 stops in use on this board, and I've soldered a ground wire to this little ground, you can see it's marked ground there, to our little ground pad, and that goes along to the LED ground connection on our stops circuit board. So I'm going to zoom the camera back out now and connect this board back up, or plug it in as I should say, to the controller, and then we'll have a look and see if everything works. Okay, so I've got this zoomed out, it's plugged into our controller again, and as you can see from the computer over here, I've restarted the control board. So you always need to do that when you plug anything into any of these sockets on the main control board. The actual computers that run this thing just do a scan at startup, and they look to see what's plugged in, because you can save some time by not polling things that are not connected. There's no point in checking to see what's going on with lighted pistons, for example, if you haven't got anything plugged into that. So whenever you make any changes, whenever you plug anything in, you need to just restart the actual control board. So that's what I've done. If we look at the computer here, so we can see we've got our normal power management stuff that's told there, and we've got our controller ready message there. We've got the two MIDI messages that have come in, which is a part of our power management thing. Other than that, not a lot going on. So I've got this ground wire connected for the LEDs. So if we bring this board in now, we can see that that's connected to this point, this ground point. And we've got these two ribbon cables plugged in. So this is the one for the LEDs, 14-way one, and this is the 20-way one for the matrix. So let's plug these into our control board, our lighted rocker tabs interface now, like so. And if we can turn this board over so that we can actually see what's going on. So at the moment, obviously none of the stops are lit, and if we look at the computer again, there's nothing going on there. But if I press these stops now, then if everything's working correctly, they should light. So we can do that. Yes, they do. And we can work our way along, switching on whichever ones we want. And if we look at the computer, you can see that it's said it's sent note on for the various ones that we've operated, which were 0, 1, 2, 3, and then 8, 9, 10, 11 and 13. And then you can see over the left hand side here in the MIDI column that it's sent MIDI note-ons for those corresponding numbers. And of course the opposite is true, so we can just switch them off as well. And you can see that that's come up on the computer and given us the corresponding note-offs. So that's all good news. We can also do it the other way around whilst we're at the computer. If we send a note on 0 like that, you'll see that stop 0 lights up, and a note off, it will go off again. So and that goes for all of them. So if I just run this up the keyboard, you'll see that they go on up and back down as I move the mouse around. So that just shows really how easy it is to do this. All it took in terms of any kind of soldering work was just to put these little links in. On this board we had to connect up the negative for the LEDs, which was just one wire, but other than that it literally just plugs into here, and that's the idea why we use the 16x2 matrix and why we've got these little plugs and sockets here. Another feature that we should look at whilst we've got all this on the bench is that if we flip this board over, I mentioned earlier that it's got all the diodes on the reverse side of it, and different boards occasionally have the diodes facing in the opposite direction to what these are. So obviously they need to face the correct way for this to work, and if they don't, it won't work at all. So what we've done is that on the main board here we've got these 4 different jumpers at the back, and there's room for some more for later developments if we add more features. But the one on the far left here, it's marked LS Polarity, and that stands for lighted stops polarity. So with it in its current position, it expects these diodes to have their cathodes connected towards the common line or the column line. It always gets confusing, but I think you know what I mean. So I'll put a little drawing here just for a moment so you can see what I mean. So the anode of the diode is usually connected to the row, and the cathode of the diode usually connects through the switch to the column. So that's how this one works, and obviously if I can turn it over again without tangling myself up, so now you know we can press this, that all works fine, and happy days. However, if the diodes were the other way round, then that wouldn't work. So just to demonstrate that, what I'm going to do now, if you look at the computer here for a moment, you can see where I switched those 2 stops on. I'll just turn on a couple more and then turn them off again so you can see that's all working. But what I'm going to do now is I'm going to change the position of this jumper. And that will make no difference at all as yet, because it only gets updated, the position of that only gets updated when the main control board boots up. I mentioned before that the computer microprocessor in here does a scan to see what's connected to it and what it's got to do with it all, and part of that scan is to check the polarity of these. So if we come back to the computer for a moment, as I said, I'm pressing these, that works fine, and we'll turn them off. So if I just close this session for a moment and then reopen it, that will reboot the controller. So now when I press these, nothing happens. Okay, they don't work at all. The lights are not coming on, and there's nothing on the computer, as you can see. So if I put this back into the other position like that, again, still doesn't work. But if we reboot it by closing the session and starting a new one, okay, and now as you can see it works again. So that's just something to bear in mind. It doesn't matter which way round the diodes are on your board. All that matters is that we set this jumper to be the correct way round for the diodes that are on your particular board. So I'm just going to zoom this in for a moment now. Okay, there we are. So now we can just see, as I was saying, so it's LS polarity is the lighted stops polarity, and then there's some others here, which is LP polarities for lighted pistons. So it does the same thing for your lighted pistons. Lighted piston mode, which we'll talk about in the lighted piston video, and the 7-segment display, whether one of those is in use or not, and that will be covered in the auxiliary board video and instruction manual. Okay, so there we are. So we're back where we were. Everything turns on, everything turns off, and we can see all the MIDI and everything else on the computer here. So staying with the computer for a minute, let's get rid of this, because with Windows you can only have, don't want to do that, with Windows you can only have one device accessing a particular port at once. So if MIDI aux or Pocket MIDI, as that was, is accessing our MIDI port, then Hauptwerk won't be able to. So let's fire up Hauptwerk and we'll take a quick look at how that works. I'm using the old version 4, the free edition, so we click continue. Okay, so just check general settings MIDI ports. Our Turtle Beach interface is listed there and it's ticked as console MIDI in, and then at the top MIDI out ports, it's also the same interface. Turtle Beach USB is ticked as console MIDI out, so that's good news. So we'll get rid of that, and then we'll load our organ. In this case it's going to be the St Anne's Moseley organ, which comes with Hauptwerk. Okay, and there we are, so that's working. So what we want to do now then, let's say that we wanted our first stop. It's open diapason 8. Have we got one of those on there? Well, it looks like it. We've got open diapason something or other, it says there. But let's just choose that for the heck of it. So all we need to do is just right click it and do auto detect MIDI trigger settings. And then we operate our stop on, and you can see that it's come up, this is lit up on the screen here, and then we operate our stop off again, and it's already ticked this for us, but it says send matching MIDI output to control this MIDI draw knob, tab or switch, and the MIDI output is our Turtle Beach, so we just say done. Yes, good, right. So now we press that, and as you can see it operates on the screen, the stop lights up, and we can turn it off. That works too. Equally, we can turn it on the screen, and as you can see the stop lights up, and when we turn it off it goes out again. And it really is that simple. So what else have we got? Just do another one. So let's do the trumpet, the 8-foot trumpet. So auto detect, we've got an 8-foot trumpet here, so we turn that on, we turn it off again, and we click done. And now if we operate this from the screen, you can see that it switches on, and we'll turn it off from the stop just for the hell of it, so that turns it off on the screen. So that's all easy peasy. Grand Org works in exactly the same way, so if you're using that, that's all you've got to do with that, and that's pretty much it. That's how you use it. It really is that simple. So whilst there's this little bit of soldering to do here, after that it really is plug the stuff in and then just right click the stuff in Hauptwerk and do auto detect, and everything's done for you. So I'm going to shut Hauptwerk down now, get rid of that again, and then just coming back to this now, let's take a look at the bigger the 48 stop version, and see what the differences are with that. Okay, so this is the big brother to the one that we've just looked at, and this works in exactly the same way. It's really simple to understand. It looks a bit more kind of intimidating because it's got lots more solder pads and components on the board and more sockets and everything, but all this is really is 3 of the ones that we've just looked at on one board. So 3/16 being 48, that's why it's a lighted rocker tabs 48, the other one was a lighted rocker tab 16. And the idea of course is that if you've got 3 of these boards on your organ, and most organs do, they're not always filled up with all 16 stops as we said before, so you might have one of these boards with 10 stops on it for your pedals, you might have one with all 16 for the grate, and you might have 14 for the swell, say, which means you're going to have 6 of these connections on the back here. So all you need to do with this is exactly what we did before with the 16, but you need to do it 3 times. So we've got our ground connection here, we've got all of our solder pads here where we can select what's connected to what, just as exactly the same as what we just did, and then you've just got that 3 times. So if we get my little test lead, it's plugged into the main board here, and we can see on the computer exactly the same as before, so we're starting from scratch. But if I use my little test lead and I connect column 1 to row 1, then you can see it says sent note 0 on. So that's the first stop is switched on now, and then if we do it to row 2, obviously that sends the note off. And then all that happens is this is 1 through 16, or 0 through 15 actually, in the way the computer deals with it. And so this is going to start off at 16. So if I do column 1 to row 1 on the second one, you can see it says note 16 on. Column 1 to row 2, sorry, we'll switch it off again, so note off 16. And then over here, this is the third matrix, and this is just going to carry on. So we do column 1 to row 1, as you can see, 32 on. Column 1 to row 2 is 32 off, and then right to the very end, column 2 to row 15 is note 47. Column 2 to row 16, row 16 turns it off again. So that's how that works. If you have got this board, or one of these boards with, say, only 10 stops on it, and you plug that into the first matrix, then it will be note numbers 1 through 10 or 0 through 9, which will turn those stops on and off. Well, actually it will be double that, but you get the idea. So what will happen then is that stops 10, 11, 12, 11, 12, 13, 14 and so on just won't exist, and those notes won't come up on the computer. So when you get your second one of these, which is, say, for the grate, and that's got 16 on it, this first matrix is only going to see our stops 1 through 10 operating. The others won't be there, and then it will just carry on at 16 through to 32. And so on and so forth. And then, just to make it even more exciting, again, as with all of the System 1 products, you can daisy chain these together. So we can just plug another cable from here, Cat5 cable or Cat5 type cable from here into another one of these, or into another 16 if you had 4 of these boards in your organ. If it was a largish organ, you'd have 3 connected to this one, and then, say, the fourth one connected to a lighted rocker tab 16 interface, which just plugs into there. And then the way that would work is these would be numbered by the computer, the MIDI that would be sent, for stops 1 through 48, and then this would start at 49, and so on the next interface up to however many you had on there. And the whole system, you can have up to 128 lighted rocker tabs connected via these interfaces. So I think that's probably all there is to say, other than there are organs obviously that do not use these, and may possibly not have a 16 by 2 matrix. But that's not a problem, because if you're rewiring those things anyway, you're going to be connecting to these. All you need to do is make sure that it's wired in a 16 by 2 matrix, and if it isn't, then if you're creating the thing, you can just make the 16 by 2 matrix yourself. And there's 1 or 2 videos, I think it's the Palladium Galanti organ I did, which I connected to this. We couldn't use it, didn't have one of these boards, so we couldn't use these plugs, so I connected it all to here, and that worked just fine. So I can't remember, that one's in a bunch of different episodes, that video, and it's the one that deals with the stops and so on. So you can see in that how I did that. You can also see in there, there's a good tip for making the bridges for these. So obviously it wasn't that organ, because we didn't do it on that organ, but one of them anyway, one of the refurbishment videos that I did, where we use this, it shows how to bridge those together, because I tried various different ways, and if you just get a bit of wire and kind of hold it across the two and solder it together and then cut the end off, that seems to be fairly unreliable in terms of it actually making decent solder joints. And if you try and bridge the solder pads together just with solder, they're not quite close enough together, so that doesn't work. And so what I ended up doing in the end is just folding the wire around a 4mm drill, and then cutting it to length and then popping that through the holes, and that gives you a really nice sort of finish to it. But anyway, that's enough of me waffling on, I think. The next video is going to be about lighted pistons, and there are a whole different bunch of interfaces that we do for that, because there are a whole different bunch of ways that lighted pistons can be set up. So that video will be out probably in another couple of weeks' time. But for the time being, that's it for this one, and I shall see you in the next video.